Hey there, science fans! Bill Nye here, ready to unravel the electrifying world of voltage and resistance. Today we're diving deep into the fascinating concepts that power our everyday lives. From the moment you flip a switch to turn on a light, to the complex circuits in your favorite gadgets, voltage and resistance play a crucial role. Get ready for a wild ride. We're going to explore how these two elements interact and make the magic of electricity happen. Imagine the thrill of a roller coaster, the burst of fireworks, and the excitement of discovery all rolled into one electrifying journey.
Think of electricity like a flow of tiny charged particles called electrons. These electrons are the fundamental building blocks of electrical energy. They move through conductors, like wires, creating a flow of electric current. This movement is what powers everything from your smartphone to your refrigerator. They're zipping around all the time, just waiting for a chance to do some work. When you connect a battery to a circuit, you're providing a path for these electrons to travel. The speed and efficiency of their movement depend on two key factors: voltage and resistance. Voltage and resistance are like the two main ingredients in this electric recipe. Voltage, measured in volts, is the potential difference that drives the electrons through the circuit. It's like the pressure that pushes water through a hose. The higher the voltage, the more forceful the push. Voltage is the driving force, the push that gets those electrons moving. When you flip a switch, you're completing a circuit, allowing the voltage to push electrons through the wires and power your devices. This push is essential for the functioning of any electrical system. Resistance, on the other hand, is like a hurdle course, trying to slow them down. Measured in ohms, resistance is the opposition to the flow of electrons. It's like friction that slows down a moving object. Different materials have different levels of resistance. For example, copper has low resistance and is an excellent conductor, while rubber has high resistance and is an insulator. The relationship between voltage, current, and resistance is described by Ohm's law, which states that the current in a circuit is directly proportional to the voltage and inversely proportional to the resistance. This means that if you increase the voltage, the current increases, but if you increase the resistance, the current decreases. Understanding this relationship is crucial for designing and troubleshooting electrical circuits. For instance, if a circuit isn't working properly, you can use a multimeter to measure the voltage, current, and resistance to identify the problem. By adjusting these factors, you can optimize the performance of the circuit. In practical applications, engineers and scientists use their knowledge of voltage and resistance to create efficient and reliable electrical systems. Whether it's designing a new electronic device or improving the power grid, understanding these concepts is key to innovation and progress. From the smallest electronic gadgets to the largest power plants, voltage and resistance are at the heart of it all. They ensure that we have the power we need, when we need it, and in the most efficient way possible. So next time you charge your phone or turn on a light, remember the incredible science behind it. Thanks for joining me on this electrifying journey. Keep exploring, keep questioning, and stay curious. Until next time, this is Bill Nye, signing off.
Imagine a water slide at a water park, you know, those tall winding slides that twist and turn, sending you plummeting into a pool of water at the bottom. They're thrilling, right? The anticipation builds as you climb to the top, and you can feel the excitement in the air. The higher you go, the more exhilarating the ride promises to be. The higher the slide, the more potential energy the water has at the top. Right? This potential energy is what makes the ride so exciting. As you stand at the top looking down, you can almost feel the energy waiting to be released. When you finally push off, gravity takes over, converting that potential energy into kinetic energy, propelling you down the slide at thrilling speeds. That's kind of like voltage. In the world of electricity, voltage is like the height of that water slide. It represents the potential energy that can be converted into kinetic energy to do work. Just as the height of the slide determines how fast you'll go, the voltage determines how much energy is available to move electrons through a circuit. It's the electric potential difference between 2 points. Imagine 2 points in an electrical circuit, one with a higher potential energy and one with a lower potential energy. The difference in energy between these 2 points is what we call voltage. It's like the difference in height between the top and bottom of the water slide. The bigger the difference, the higher the voltage, and the more oomph those electrons have. Just like a taller slide gives you a more thrilling ride, A higher voltage gives electrons more energy to move through the circuit. This energy is what powers our electronic devices, from tiny gadgets to massive machines.
Think of a regular AA battery. It's a common household item, used in everything from remote controls to flashlights. But have you ever wondered how it works? Inside that small cylinder is a chemical reaction that creates a difference in electric potential between the positive and negative ends of the battery. It has a voltage of 1.5 volts. This means there's a 1.5 volt difference in electric potential between the two ends of the battery. It's not a huge amount of energy, but it's enough to power small devices. When you connect the battery to a circuit, electrons flow from the negative end to the positive end, driven by that voltage difference. That's a pretty small push. In the grand scheme of things, 1.5 volts is relatively low. It's like a small water slide. Fun, but not particularly thrilling. It's enough to get the job done for low-power devices, but it doesn't pack a lot of punch. But now imagine a car battery, packing a whopping 12 volts. This is a much higher voltage, and it provides a lot more energy. Just like a taller water slide gives you a more exciting ride, a higher voltage gives electrons more energy to move through the circuit. This is why car batteries are used to power much larger and more demanding systems. That's a lot more oomph to get things moving. With 12 volts, a car battery can power the starter motor, lights, and other electrical systems in a vehicle. It's like the difference between a gentle slide and a thrilling plunge. The higher voltage provides the energy needed to get things moving quickly and efficiently. So next time you think about voltage, remember the water slide analogy. The higher the slide, the more potential energy at the top, and the more thrilling the ride. Similarly, the higher the voltage, the more energy available to power our devices and systems.
Not quite. Now let's talk about resistance. Resistance is a fundamental concept in the world of electricity and electronics. It plays a crucial role in how electrical circuits function and how we can control the flow of electric current. But what exactly is resistance, and why is it so important? Picture a narrow hallway crammed with people trying to get through. Imagine you're at a concert, and everyone is trying to leave at the same time through a single exit. The more people there are, the harder it is to move and the slower everyone goes. This is a perfect analogy for understanding resistance in an electrical circuit. It's going to be a tight squeeze, right? That's resistance in action. In an electrical circuit, resistance is the opposition to the flow of electric current. Just like the crowded hallway slows down the movement of people, resistance slows down the flow of electrons in a circuit. It's the opposition to the flow of electric current. When electrons move through a conductor, they encounter obstacles that impede their flow. These obstacles can be atoms, impurities, or other factors that create resistance. The higher the resistance, the more difficult it is for the current to flow.
Different materials have different levels of resistance. Conductors, like copper and aluminum, have low resistance, allowing electrons to flow easily. Insulators, like rubber and plastic, have high resistance, preventing the flow of electrons. This is why we use copper wires for electrical connections and rubber for insulation. A copper wire, for example, is like a wide-open highway for electrons. Very little resistance. Electrons can move freely through the copper, making it an excellent conductor of electricity. This is why copper is commonly used in electrical wiring and components. But try sending those same electrons through a rubber duck, and they'll hit a wall. Rubber is an insulator, meaning it has high resistance. Electrons cannot move easily through rubber, which is why it's used to protect us from electric shocks. Rubber is a great insulator, meaning it has high resistance. This property makes it ideal for coating electrical wires and creating safe, non-conductive surfaces. By understanding the resistance of different materials, we can design circuits and devices that are both efficient and safe. Now, let's dive a bit deeper into the concept of resistance with Ohm's law. Ohm's law is a fundamental principle in electronics that relates voltage, V, current, I, and resistance, R. The formula is simple. V equals IR. This means that the voltage across a conductor is equal to the current flowing through it multiplied by its resistance. By using Ohm's law, we can calculate the resistance in a circuit if we know the voltage and current. This helps engineers and technicians design circuits with the desired properties and troubleshoot issues when things go wrong. Resistors are components specifically designed to provide a precise amount of resistance in a circuit. They come in various sizes and values, and their resistance is indicated by color codes. By selecting the right resistor, we can control the current flow and voltage levels in our electronic devices. In summary, resistance is a key concept in understanding how electrical circuits work. It determines how easily current can flow through a material and helps us design safe and efficient electronic systems. Whether it's a simple circuit in a flashlight or a complex motherboard in a computer, resistance plays a vital role in making it all work. So, the next time you hear the phrase, resistance is futile, remember that in the world of electronics, resistance is not only essential, but also fascinating. It helps us harness the power of electricity and create the incredible technology we use every day. Section 4. Voltage and resistance. A dynamic duo. So, how do voltage and resistance work together?
Think of it like this. Voltage is the driving force and resistance is the brake pedal.
High voltage wants to push lots of current through, while high resistance tries to hold it back.
The relationship between voltage, resistance, and current is summed up by Ohm's law. Voltage, V, equals current I times resistance, R. It's like a mathematical recipe for electricity.
Section 5, let's wrap it up, and there you have it, folks.
Voltage and resistance, the dynamic duo of the electrical world.
Remember, voltage is the push, and resistance is the brake. They're both essential for making all our cool gadgets work.
Thanks for watching, and don't forget to subscribe for more electrifying science adventures. Bye for now.